You've conquered roller coasters, climbed mountains, braved haunted houses. Heck, maybe you've even thrown yourself out of a plane. But if you're an adrenaline junkie craving a real thrill, come one, come all to Algebra 1's newest attraction, solving equations with exponents and radicals. Buckle your seatbelts and keep your hands and feet inside the vehicle at all times. You're about to embark on the ride of your life. Hi, my dears. Welcome to Class 8 of Unit 6, Equations with Exponents and Radicals, Part 1. The idea is that now that we know how to use our laws of exponents and our properties of radicals to break down and simplify expressions, just as we've done in the past, our goal now is to take what we've learned and use it to help us solve equations. The only question is how. So say, for example, I've got something like this. The square root of the quantity x minus 2 equals 5. This is an example of what we call a radical equation, which you may remember we said at the beginning of Unit 6. In fact, we said it with this exact equation. It is an equation that has a variable inside of a square root or a third root or a fourth root or a fifth root. If my goal is to solve it, it might help to remember what we're trying to do. Remind me, three-part question. What does it mean to solve? What am I trying to do by solving? And how do I go about doing that thing? 30 seconds, pause the video, three-part question, go, go, go. And stop. You may remember, and hopefully you haven't forgotten, to solve an equation means to make it true. In order to solve an equation, my goal is to isolate the variable. And in order to isolate the variable, the strategy that I use, the way that I do that, well, I'm going to deploy my old friend. I'm going to use some inverse operations. So for example, if I have the square root of x minus 2, if my goal is to get x by itself, well, I need to get rid of the negative 2. But before I can touch the negative 2, remember that a square root, a cube root, a fourth root, just like absolute value, just like a fraction bar, just like parentheses, these are grouping symbols. So I can't touch the minus 2 until I get rid of the square root. So the question that we now need to ask ourselves is, if I want to get rid of that square root, I need some kind of inverse operation. So what do you think I could use to undo, in this case, a square root, but really any nth root? If I want to get rid of this square root, what would, as we've seen, its inverse operation be? Think strategically about the stuff that we've done this far. How could I undo a square root? Go! 5, 4, 3, 2, 1, and stop. Well, as we've seen a bunch of times in our unit so far, the opposite of a radical is an exponent. So if I'm trying to undo an nth root by taking the nth power, I can put myself in a position where those two things will cancel each other out. So if I want to get rid of a square root, what power should I use? 5, 4, 3, 2, 1. Stop. Emphasis on that 2, because to undo a square root, well, the opposite of a square root we've seen is a square. So on the left, I'm going to square so that my square and my square root cancel each other out. But remember that this is an equation. So if I square the left side, I also need to make sure that what happens? Well, what I do to one side, I do to the other. So if I square the left side, I need to square the right side as well. So on the left, the square and the square root, they're inverses, they cancel out, and I'm just left with the argument of x minus 2, the stuff inside of my radical. And on the right, I now have 5 squared. Well, 5 times 5 I know is 25. To get x by itself, all I need to do is add 2 to both sides. Look at that. X equals 27 is my answer. Fantastic. With this idea in mind, let's amp it up and try it with these two. I want to solve for n, solve for p. Use what you know about inverses of radicals to isolate your variable. Go! and stop. So on the left, I need to get rid of a square root. To undo a square root, I should use a square. If I square one side, I'm going to square the other as well. So on the left, 5 squared again, we just saw is 25. And on the right, our square and our square root cancel out. We're left here with the 1 minus 3n that was stuck inside of that radical. Now that I've gotten rid of the radical, I can now isolate n as normal. Subtract 1 from both sides. This leaves me with 24 equals negative 3n. Divide both sides by 3 to get n by itself. Here we know that 24 divided by negative 3 would be negative 8. For p, I now need to get rid of a cube root. Well, the opposite of a cube root is a cube. If I cube now the left side, I'm going to cube the right side as well. On the left side, cubes and cube roots cancel each other out. I'm left with the 2p plus 5 inside of the cube root. And for negative 3 cubed, well, negative 3 times negative 3 is 9 times negative 3 gets me negative 27. To get p by itself, inverse order of operations, let me now do some minus 5 to both sides. 2p is equal to negative 32. We'll divide both sides by 2 to isolate p. P is equal to negative 16. Beautiful, beautiful, beautiful. Now, just like we can use squares and cubes to get a variable out from inside of a square root or a cube root, we should also be able to use some radicals as inverse operations to get a variable out from inside of an exponent. So say, for example, I've got something like this, x squared equals 25. My goal is to isolate x. By the way, if you're interested, this is an example of a polynomial equation, which we also said at the beginning of Unit 6. This is an equation that contains some combination of variables and numbers that are adding, subtracting, multiplying, and dividing by each other, often containing exponents. My goal here is to get x by itself. What do you think I'm going to do to get rid of that square? 5, 4, 3, 2, 1. Well, I know the opposite of a square is a square root. So I'm going to take the square root of both sides of this equation to get rid of the square. So here, I know that a square root and a square will cancel each other out. On the left, I'm just left with x. On the right, though, I have the square root of 25. Well, what number multiplies by itself to get 25? It could be 5, but is 5 my only answer? Well, no. Remember, it could be positive 5 times positive 5, or negative 5 times negative 5. So here is where that idea, whenever we take a square root, we add back in a plus or minus. This is where it comes in really important. Plus or minus 5 is my final answer for x. It could be either the positive or the negative version. Fantastic. Let's take those same ideas and scale them up just a little bit. Let's say that I want for the equation on the left to solve for y. What would I use to undo that power of 3? Again, I can't touch the 3 minus 5x inside until the cube goes away. What would the inverse operation here be? 5, 4, 3, 2, 1. Alrighty, well here, I'm going to take the cubed root of both sides. If I want to undo a cube, well, a cube root is going to be my best bet. On the left, the cube and the cube root cancel out, and that leaves me with the 3 minus 5x inside of those parentheses. And on the right side, I'm now taking the cube root of 8. What number multiplies by itself 3 times to get 8? Well, that would be 2 times 2 times 2. All I need to do now is solve for x. Well, let me start by subtracting 3 from both sides. Negative 5x is equal to negative 1. We'll divide both sides by negative 5. X here should be equal to positive 1/5. For this guy here on the right, I'm going to solve for z. I have z plus 1 quantity squared, so in parentheses, squared, equals 9. What's my move going to be here? Go. 4, 3, 2, 1. Alrighty, I want to get rid of a square. Let's take the square root. So on the left side, the square root of a square, the square root and the square cancel out. I'm just left with the z plus 1. And on the right, the square root of 9 could be either positive or negative 3. Now I need to think about how I would make sense of this guy. What do you think I'm going to do with this plus or minus? Because that's technically two numbers in one. How do you think I could use that plus or minus to my advantage? Take 30 seconds. Take a risk, take a chance. What do you think? Go. All right. Well, let's harken back for a second to Unit 2. Remember when we were working with some compound inequalities? When we had an OR statement, remember that we could break it down into two cases. So if I have positive 3 or negative 3, I'm going to make a case for each. So z plus 1 could be positive 3, or z plus 1 could be negative 3. And from here, now that I've split this up, I can solve for z. Subtract 1 from both sides in both cases. On the left, we see that z could be 2, or on the right, we see that z could be negative 4. Fantastic. Let's do 3 more to practice this idea, and then you're free. Go, go, go. Use some inverse operations. Let's find the values of a, b, and c. And stop. For number 1, my goal is to get a by itself. Well, if I want to undo a square, let's use a square root. Taking the square root of both sides, on the left, the square root of a squared is just a, and on the right, the square root of 32. Again, 32 is not a perfect square, but it does contain a perfect square in its factors. Using our properties of radicals, I can break this down as the square root of 16 times the square root of 2, which means that a would be equal to the square root of 16 is plus or minus 4. Smush it right back up against that root 2. For number 2, I need to take the cube root of both sides to get rid of that cube. So the cube root and the cube on the right cancel out. That leaves me with the 2b plus 1 inside of my cube. The cube root of negative 64, well, the number that multiplies by itself 3 times to get negative 64 would be negative 4 times negative 4 times negative 4. To get b by itself, let's subtract 1 from both sides. That leaves me with negative 5 equals 2b. To get b by itself, I'll divide both sides by 2. Negative 5 over 2 is the value of b. And for number 3, I need to get c by itself. It's inside of a square. Let's use a square root to undo it. On the left, my square root and my square cancel each other out. That leaves me with c minus 7. And on the right, I have plus or minus 2 as the square root of 4. Again, I've got a plus or minus, so that's 2 separate options. I'm going to create 2 cases. In my first case, c minus 7 could be the positive 2, or in the other case, c minus 7 could be the negative 2. If c minus 7 is equal to 2, well, adding 7 to both sides would reveal that the value of c is 9. And if c minus 7 is negative 2, adding 7 to both sides would reveal that c could instead be positive 5.